Hey students, we have a question here that in a circle AB and AC are two equal chords with center O. If OD is perpendicular to AB and OE is perpendicular to AC, prove that ADE is a isosceles triangle. So basically, we have a question that in the same series, we have a question that a circle having center O and there is a two chord between where we have a question that ADE, that is the triangle which is formed by that particular two chords will be isosceles. Okay, first of all, we have to understand that what is isosceles triangle. Okay, when two sides of a triangle are equal, then it is called the isosceles triangle. Whenever we have a triangle, there is two equal sides. When there is a two equal sides and one is not equivalent to that both the sides, this uh, this triangle is called isosceles triangle. So first of all, we have to understand this question by making the proper diagram. Okay, so we are starting with the diagram here. Now, sorry, we starts with the diagram so that we can understand it easily. Here we have a diagram. Okay, here we have a figure. Make it thicker so that we can easily understand it. Okay, and change the color. So this is our circle here, and basically the question says that we have a we have two chords over there. So making chord here. So making chord here, make it thicker so that we can understand it easily. Okay, and another one will be from here to here. Okay, so that we can easily understand it. Okay, these two chords in a circle, name them, that is AB and AC. Okay, so first of all, we have to mention the name here, that is A will be here, and that is B will be here, and that is C will be here. Now, at the center, first of all, we have to make a center here. This is the center. Okay. Now, this is the center, and center will be O. Name it as O. This will be center here. From this center, we have a perpendicular. Okay, then we have to make a perpendicular according to the question that we have to make a perpendicular over here. Okay, make it more thicker so that we can easily understand it. And another one will be from also from here to here. This is the perpendicular to AB and AC. Okay, these are perpendicular. Okay, so name it as D. D will be here, and E. Sorry, E, E will be here. Okay. Now OD is perpendicular to AB and OE perpendicular to AC. Okay then. Uh, so now there is a line between D and E. Okay. This is the line between D and E so that ADE. ADE is the triangle here. According to the question, we have to prove that this triangle, basically, this triangle will be isosceles triangle according to the question. So we have to prove that this very triangle is isosceles. Now, what will be the approach? First of all, what we have to find out. Okay, so basically we have to find out uh, the triangle. So start with the given. What we have. Okay, what we have so that we can understand what is the question here. Okay, now so we have this one. This is given to us. Clear? It is given to us. And what we have to prove, what we have to prove is to prove what we have to prove. What we have to prove is ADE is an isosceles triangle. Now, there is little bit a construction between this. Some construction is there so that we can easily uh, solve our question here. So, making a line from A to O, join A to O. Okay, so join AO. Okay, basically we have joined the AO so that we can easily understand what we are doing and what we are comparing here. Ah, okay then. Now proof. Now we are starting with proof. Okay. So first approach is both are uh, both the OD and OE are perpendicular to AB and AE. So we have what we have. We have AB equals to AC. Okay, because both the chords are equal. and OD equals to OE. Okay, these both are equals, and so equal chords are equidistant from the center. Okay, therefore, since because of the theorem that is equal chord, sorry, equal chord are equidistant from the center. Okay, so adjust it on the screen so that we can easily understand it. Sorry, here we are doing here. So OD equals to OE. Yeah. Now in triangle, sorry, in triangle that will be AOD. This one A O and D, AOD and triangles AOD and triangle AOE. That will be AOE. Okay, we can change it, change the color so that we can easily understand it. What is the basic difference? So marking it as a first, okay, and this will be triangle AOD and AOE. So basically we have OA equals to OA, that is common, that is common here, and OD equals to OE, that will be from first and first, okay, and triangle, sorry, and angle OTA equals to angle OEA, that is right angle, right angled, right angles. So, so by RHS congruence, congruence criterion, we have, so we have triangle, triangle AOD is congruent to triangle AOE. Okay, both the triangles are congruent. Which one? This triangle and this triangle. Both are congruent here. Okay, both are congruent. So basically, when these two triangles are congruent, then then AD equals to AE. That is that is AD equals to AE. Okay, by 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 CP. Okay, what is CPCT? CPCT here is corresponding part of congruent triangle. Okay, then hence triangle ADE is an isosceles triangle. So when when this one, and this one both are equal, this AD and this AE will be equal, then this triangle, whole triangle will be, then the whole triangle will be isosceles triangle. Okay, as we have proved it. Yeah. Okay. Okay, I'm zooming out so that you guys can easily understand it. Yeah, the whole question. Okay, thank you guys.